Okay, good morning, grade 8. Our lesson today is chapter 7, lesson 3. We're going to continue the lesson, but before we're going to continue, I want to refresh and warm up with what we have learned the last lesson. Triangle similarity, AA, SSS, SAS. Okay, I have three kinds of similarity. The first kind is AA, and it stands for angle-angle similarity, and SSS and stands for side-side-side similarity, and SAS and it stands for side-angle-side similarity. Okay, and the first similarity here, I'm going to review it. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. If I have A and D, they are congruent. B and E, they are congruent. So triangle A, B, C and triangle D, E, F are congruent. Okay, girls? And we explained the example, this one. Since PT and SR are parallel, so from the alternate interior angles, angle P and angle R will be congruent, and angle T and angle S will be also congruent. Therefore, triangle PQT is congruent to triangle RQS. Girls, can any one of you tell me what is the difference between two triangles are congruent and two triangles are similar? Or any shapes between two shapes are congruent and two shapes are similar? Can anybody tell me what is the difference between congruent and similar? Who will tell me? Girls? Okay, two shapes or two triangles are congruent if they have the same shape and the same size. Same shape, same size. Same shape, same size. I can call two shapes congruent if they have same shape, same size. Two triangles and the two triangles have the same size. All their lengths are the same. But what about similar? Two shapes or two triangles are similar. Both have the same shape, but they do not have the same size. Okay? But their corresponding sides are similar. They have the same ratio. They are not similar, they have the same ratio. Like what we have learned in the first lesson. When I put the first side from the first triangle over this first side from the second triangle over each other, they will give me a ratio. The ratio should be equal in the three sides in the two triangles. Okay, this is called similar. They have the same shape, okay, but they do not have the same length, but they have the same ratio. They have the same ratio. Okay, girls? Let's continue. The second similarity, SSS. What is SSS? It is side similarity. If the three sides of one triangle are proportional to the three sides corresponding to the three corresponding sides of another triangle, then the triangle are similar. Again, if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. Like AB over DE equals to a ratio. It is the same like AC over DF. It is equal to the same ratio of BC over EF. And when I am choosing the Sides, I will choose from ordering of the letters here. AB over DE. AB over DE, the red lines. BC over EF, the blue lines. AC over DF, the green lines. Then we learned an example here, PQR and PRS, PQR and PRS. I'm going to take PQ and PR. PQ is 4 over PR, which is 6. 4 over 6 is 2 over 3. QR and RS, 4 over 6, which is 2 over 3. PR, the first and the third, and the first and the third here is 6 over 9, which is 2 over 3. Okay, what is new today? The new today is the third similarity, which is SAS, side angle side. If two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the two triangles are similar. Like, I have AB here, and I have DE here. The pink lines, you see? The two sides here are proportional. And I have BC and I have EF. They are proportional. I will not stop here. This is S and S. What about A here? I took this side and I took this side. I will take the angle in between. I took this side and the angle in between. If the angle in between are congruent, so the two triangles are similar. So the two triangles are similar. Okay. Okay, girls, let me show you.
You know, sometimes we can actually use similarity to figure out a particular question. Let me show you what I mean. So here I'm just given this figure with all the data as shown. So I'm told that this line PQ is parallel to this line ST. I have a few lengths here, and our job is to figure out the length of SR. We've got to figure out that length. Well, it seems like maybe we don't have enough information because, wow, I don't know a lot of stuff. I just know a couple of things here. These are parallel. How could I possibly proceed? Well, this is where the power of similar triangles come into play. If we can show these two triangles are similar, then we can set up a appropriate proportion. Well, let's take a look and see. Well, since this line is parallel to this line, I can think of this as a transversal. I know alternate interior angles are congruent, so I know that this angle right here is going to be congruent to this angle way over here. Similarly, if I look at this transversal, I see that this angle here is going to be congruent to this angle here. These two angles are vertical.
Just wait, girls. I want to show you another one concerning SAS.
Let's take a look at that side is equal to 3 over 2. Immediately, so when I compare this side, okay, another important theorem is the side angle side similarity.
This video, this part will show you SAS
theorem. By the way, do you notice that some of these have familiar names, like the side similarity theorem, the side angle side similarity theorem, to showing triangles are congruent, right? If we had side all being congruent to corresponding other triangle, then the two triangles are congruent. Here, if we just sort of slightly weaken the condition, then we get similarity. So you can see parallels with with other results. Anyway, side angle side similarity. If two sides of one triangle are proportional to two sides of another triangle, and the angle included between them are congruent, then the triangles are similar. So if this side is proportional to this, and this side proportional to this, and they're the same, so that the proportion of these pairs are equal, and this measure of this angle, in fact, is equal, these two angles are congruent, then we can conclude by side angle side similarity, these two triangles are similar. So let's take a look at a little example where we can use this fact. So here I'm given two triangles. Do you see both triangles? It may be sort of hard to see. One is this huge triangle, BDA.
Girls, focus here that angle D is common. Angle D is common between the two triangles that we're going to talk about. Angle D is common. Angle D is common between triangle ABD and EDC. It is common between the two triangles. Common between the two triangles, so it means it is equal. It is equal. It is equal here in EDC and ABD.
And the other one is this sort of modest triangle in here, CDE. And I want to know if they're going to be similar or not. Well, first of all, I immediately see that side angle side similarity might be a good test to consider because they each share the same angle D. And so, of course, we know that by the reflexive property, D is congruent to itself. And so, therefore, if I can just show that this side is to this side as this side is to this side, then, in fact, I know the triangles are similar by side angle side similarity. So, let's see if that's really true or not.
So, if we're going to prove that 3 here, 3 over 15 will be equal to 4 over 20, and we have a common angle here, D. If we're going to prove this, so the two triangles are congruent.
So let's compare sides. So the big is to the small here. This would be the big is what? Well, this is 15 and this is 3, so the total is 18. So 18 is to the small 3. Well, that works out to be 6. Now, is that the same ratio as big is to small here? Well, big is what? Well, that's 20 plus 4 is 24 is to small 4. And that works out to be 6. Yes, they're the same. So since they're the same, then these guys are actually proportional. And so I see by side angle side, these two triangles, the large one and the small one, actually are, in fact, similar.
So as you see here, girls, we compared the two triangles, the smaller one and the bigger one. We compared the side of the small one, which is ED. ED is 3. And the bigger one is AE and ED together. So it is 15 and 3 together. So it is 18. And the larger one here is BC and CD. So it is 20 and 4. So it is 22. Okay, girls? Over the smaller one. And I want to tell you, if you want to start to put up the greater one, so you're going to put up the greater one in the two comparison. Over the smaller one, if you want to put the smaller one first, over the greater one down, so put it in the two comparison. So you will have 1 over 6, 1 over 6, or you have 6 and 6. Don't put in the first one up the bigger one, down the smaller one, and in the second one, the smaller one, and the bigger one down. No. Decide that you're going to put the greater one, both the first one. Okay, girls?
Teacher, you mean?
The power of similar triangles come into play. If we can show these two triangles are similar, then we can set up a appropriate proportion. Well, let's take a look and see. Well, since this line is parallel to this line, I can think of this as a transversal. I know alternate interior angles are congruent, so I know that this angle right here is going to be congruent to this angle way over here. Similarly, if I look at this transversal, I see that this angle here is going to be congruent to this angle here. These two angles are vertical angles, so we know by the vertical angle theorem they're congruent. And so what do I have? I have angle, angle, angle be congruent, so therefore we know that these two triangles are similar by angle, angle, angle. Or I could, by the way, I could have just stopped with these two pairs of angles and just used angle, by the way. I guess I did a little bit of overkill, but it's okay. Either way is perfectly correct. Well, since they're similar, now I can set up a proportion and actually find this length. And the way I mark my diagram is going to be handy because it's going to show me what side is proportional to which side. It might not be clear which side goes with which side.
Okay, he proved that since PQ and ST are parallel to each other, so angle P and angle T are congruent. Angle Q and angle S are congruent. And also, angle R are also congruent to each other. So the two triangles are similar. So what is the question? Then find find SR. They want to find the measure of SR. Since the two triangles are similar, so the two corresponding sides will have the same proportions.
But now with those angles marked, it's very clear. I want to find SR. So SR is to, well, that's the side that's opposite the T of the double angle here. So that's going to be, it's to 30 as, and then what can I look at next? I can look at the 30, which is opposite the single one, is to 25. The side opposite the single angle. So you can see actually marking the angles is very important in order to figure out which side corresponds to which side. We always are talking about corresponding sides, but in this question, we've got to actually know which side corresponds to which side. Okay, now this ratio can be simplified a little bit. Get rid of a factor of 5 here, and I can write this as 6 over 5. Okay, so now I can use the cross product idea, and I see that 5SR, 5 times SR is equal to 6 times 30, which is 180. And so when I divide, I see that SR equals 180 divided by 5, which is 36. And so I see that this length, SR, is 36. We were able to find that by first realizing, in fact, these triangles in the picture are, in fact, similar.
Okay, girls, let's go back to our book. Okay, girls. Okay, girls. We have here. BBC, DBE. Okay, as it is given here, why is hearing? Okay. AC. So angle A congruent to angle B, congruent to angle C. So the two triangles are similar. Now I want to know the measure of E. This E. Since they are similar, so the two sides, every two corresponding sides are proportional. So if I take AB over DB from the two triangles, here, so here for you. If I take here AB over DB is equal to BC over BE. Okay, I want to know the measure of BE. Now, do I know AB? AB, yes, is 36. DB is 54. And BC is 54. BE, I don't. So, you know, girls, now you know how do I get the length? I have many lengths. Okay, so I'm going to choose corresponding sides because they are proportionally together. So AB over DB, AB over DB is equal to BC over BE. And I'm going to choose corresponding sides that have the side that I want to get its length. I will not choose any corresponding sides. No, I'm going to choose corresponding sides that have the side that I want to get its length. So it is BE. What is corresponding to BE? BC. So I'm going to write AB over DB equals to BC over BE. Aside from here and aside from here equal to aside from here over aside from here. And all their lengths are clear in front of me. So I'm going to use the scissors way. You know it? 54 multiplied by 54 over 36 will give me the value of BE. Again, why triangle RSD is similar to RDU? Okay, as we see here that angle R is common. So we can go from SAS. Okay? Girls, the session will be closed in maybe less than 1 minute because the session is only 40 minutes and it will be closed. So it can be closed in any second that I am explaining. If it will be closed, I will continue tomorrow because the session is only 40 minutes. If it is more, it will be closed automatically. Okay, girls, are you listening to me?
Yes.